Hi to everyone. MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject Automotive Electronics, unit number 4. Unit number 4 is Engine Control System. Okay, so in this unit, we are going to discuss about control modes for fuel control, then engine control subsystem, ignition control methodologies, different ECUs used in the engine management. So, block diagram of the engine management system, CAN standard, format of CAN standard. So diagnostic system in the modern automobile, like that we are going to discuss in the unit. First, what is engine control unit? Also commonly called engine control mode is a type of electronic control unit that controls a series of actuators and an internal combustion engine to ensure optimal engine performance. If the ECU has control over the fuel lines, then it is referred to as an electronic engine management system, EEMS. The fuel injection system has the major role of controlling the engine's fuel supply. The whole mechanism of EEMS is controlled by the stack of sensors and the actuators. Electronic control unit, also known as electronic control module, and powertrain control module, that is PCM. That means in the system we have ECU control. In input side we have variable resistor, potentiometer, switches, actuators, voltage generators, magnetic pickup, like that we have. In outside we have DC motor, solenoid, relay, display, like that we have in the output. Vehicle management is by ECU, which act as a computer. 3 stages operation: input, process, and output. ECU operation. Inputs come from sensor and switches. CPU process input reading and compares with the ideal data stored in memory. Outputs to actuators make adjustment that improve efficiency, power, controllability, and safety. So this is the simplified electronic control system, which is controlling the engine and the engine output power. First one is engine temperature sensor, which is sense the temperature. If it is overload, means it indicate to the car driver. Then oxygen sensor, NOx sensor, mass airflow sensor, vacuum controller, EGR valve. TPS, air temperature sensor, ideal actuator, fuel pressure, regulator, camshaft sensor, crankshaft sensor, diagnostic lamp, ignition coil, injector. So these are the components used in the ECU. We are getting the data from the kind of sensor. We are analyzing in the controller. Then we are giving command to the output unit. So this is the input circuit conditions. Here in ECU, that is engine control unit, we have input circuit, power supply, processing, and output circuit. So processing circuit compares information. That means what we are getting. For example, if temperature is 40 degree means, so what is the original range, it will be that. Okay, so they compare both the values then given to the driver's board. So output circuit switches actuators, power supply provide the stable power supply to voltages to all the circuit. So block diagram of engine management system. So in this engine management system, we have a different kind of sensor inputs. Okay, then we have voltage router and voltage regulator and the output side, that is transient protection, ignition coil drivers, fuel injected drivers, solenoid drivers, then solenoid drivers, data bus. These are given to the ignition coil, fuel injector, ideal speed actuator, engine gas regulation valve, and data bus. So this is the black diagram of engine management system. Engine control subsystem. Engine have the following process: intake, exhaust, fuel system, valve train, and engine electrical. So drive train, which is transmission, differential, axle, wheels. So braking system and cooling system. So electronics, that is electronic control module. 6 changes, body and frame. So ignition control methods. So mechanically timed ignition, electronic ignition, digital electronics ignition. So modern EMS read in your data from various sensors about the crankshaft position, intake manifold temperature, intake manifold pressure, threshold pressure, fuel mixer via oxygen sensor, denotion via NOx sensor, and exhaust gas temperature sensor. In an engine management system, electronic control fuel delivery and ignition timing. Primary sensor on the system are crankshaft angle, so airflow into the engine and the throttle position. This circuitry determines which cylinder needs fuel and how much open the request injector to deliver it. Then causes a spark at the right moment to burn it. Early EMS system used an analog computer to accomplish this, but as the embedded system dropped in price and become fast enough to keep up with the changing inputs at high resolutions. So digital systems started to appear. So introduction to CAN. So it is a network, CAN network. So this network we'll see in the next class. Okay, this is a different models of engine control unit. So simply we can say engine is the heart of the system. Okay, when proper working of engine, then only the car efficiency will be high. Okay, because of in engine we have more number of n number of 30 to 50 sensors will be available to monitor the monitor the process of output of engine to whether engine is working or not. What is the problem like that will be defined. So we need here uh, 4 types of process. That is, one is microprocessor unit, which is analyze the sensor values. So another one is power supply. We need to give different power supply to the different sensor because each sensor will work in the different conditions. Okay. So as well as we need to use a network for communicate these type of modules because we have 4 to 6 modules available in the car to communicate. So that is controller area network meaning. So for all the process in the synchronization manner, then only the system will be enabled. Okay, system will work in a proper manner. Okay, this is the concept of engine management system. Okay, here we have input and output devices, processor, and other devices. As well as we have onboard diagnostics. Onboard diagnostics will define the what are the errors will produce in the engine. So that will be diagnosed by the automatic system. Okay, for example, if temperature increases in the car, so automatically the system have to reduce the temperature in the cars by the increasing the cooler value. Okay, if temperature more very low means the cooler must be heated. Okay, that means the temperature level will need to be increased. So that time the system will automatically analyze then process the output. Okay, just see that is change the compressor value. These are the concept we are going to see in this whole unit. Okay. This is the complete model working of engine that is having a different process. That is engine for engine continuous process. We need a different sensor for working the condition. Okay, thank you. We will see in the next class. So next class we will discuss on the controller area network, how they transfer the data between the one location to another location with the high speed process. Okay, thank you.